people. Welcome to section A of our internal assessment 2 review. In this session, we are focusing entirely on data cleaning. As we know, data cleaning is arguably the most critical step in any data science workflow because quality of our final work analysis depends heavily on the quality of our input data. We will be covering question 1 through question 10, exploring why standardization is necessary when merging data sets and understanding the famous principle of garbage in, garbage out. We'll also look at how to handle missing values using imputation techniques and why keeping raw data separate from the clean data set is a golden rule. Let's get started and ensure how our data foundation is solid. Hi everyone. Um, in this video, we'll begin with section A of our second internal assessment of data science, which focuses on data cleaning. So, data cleaning is one of the most important steps in any data science workflow because the quality of our analysis depends heavily on the quality of our input data. Let's go through each question one by one with clear explanations. So, question number one, when merging data sets with different measurement systems, ensuring standardization or consistency between units is crucial. Whenever we merge data sets that use different units or measurement system, it is essential to ensure standardization. For example, one data set may record weights in kilograms while others use pounds. If we merge these without converting them to same unit, the resulting analysis may become meaningless. So standardization ensures that all the values follow a single consistent scale, which is critical for algorithms like KNN, K nearest neighbors, or K means that purely rely on the distance calculation. Second, in data cleaning, garbage in, garbage out stresses that analysis quality depends on input data. So this famous phrase emphasizes that the quality of our analysis depends entirely of the quality of input data. No matter how advanced a machine learning model is, cannot overcome fundamentally flawed or noisy data. That's why data cleaning consumes so much of a data scientist time. It prevents low quality input from producing low quality results. Third, uh, bias or artifacts are systematic problems introduced during the data cleaning process that can be corrected. Biases or artifacts are the errors introduced during the cleaning process itself. For example, replacing all missing age values with zero may create artificial patterns that misinterpret the data set. These are not random mistakes. They consistently affect the data set based on the rule we applied. Fortunately, such biases can be corrected by adjusting the cleaning strategy. Question 4. Irrecoverable information loss during acquisition, such as power outage, is an data corruption. When information is lost during data acquisition due to events like system crashes or power failures, we call this term as data corruption. Unlike missing values, where the data field is simply blank, corrupted data is particularly or entirely unreadable. Since the original value cannot be reconstructed, corrupted rows must often be removed entirely. Fifth, replacing missing data with the mean of existing values is called mean imputation. Mean imputation involves replacing missing numerical values with the average of the existing values in that column, which we term as mean. So this keeps the data set size intact and it's very simple to apply. However, it reduces the natural variability of the data because many values are replaced with the same central number. 6. Filling missing values via linear regression or curve fitting is known as regressive imputation. So Regressive imputation predicts missing values using relationship between the variables. For example, if the weight is missing, we might predict it using height and age. This method is more accurate than simple mean imputation because it preserves the correlation structure of the data. Seventh, always preserve both the raw and original data and the clean data set. So this is fundamental principle of data management, in which it says we should never overwrite or alter the original raw data. If a mistake occurs during cleaning or transformation, the raw data acts as a fallback. Maintaining both ensures transparency, reproducibility, and auditability. Eighth, converting John Smith to Smith, John is an example of name sanity or name quality. Name normalization applies consistent formatting rules to text field like names. Database treats John Smith and John, Smith and Smith, John as completely different values. Normalization ensures that name follow a standard format so they can be matched, merged, or duplicated reliability. 9. Outlier detection is often termed as sanity or quality check. Outlier detection is often used as sanity check to identify values that don't make logical sense, such as age of 200 or salary of $5. These suspicious values prompt further investigation, confirm whether they are valid or they are the errors. 10th, functions like Unicode help remove inconsistent characters during text or string repair. So data that often comes containing inconsistent characters, accents, or encoding issues. Functions like Unidep code converts all characters into standardized ASCII equivalents. So this ensures compatibility with databases and text processing tools, which creates cleaner and more uniform text data. So we are now done with the section A of our second internals database internal assessment. In the upcoming videos, we will deal with section B, C, and our final section, which is section D. Thank you. That concludes section A on data cleaning. We have covered how to tackle systematic errors like biases and the importance of sanity checks to check outliers. Remember, whether we are using mean imputation to fill gaps or repairing text functions like Unicode, the goal is always to create a dataset that reflects reality without artificial distortions. Keeping all these things in mind, that while advanced modes are great, they cannot fix fundamentally corrupted data. So we have to make sure to review the difference between standardization and normalization before moving on. Thanks for watching and see you in section B soon.